Hi girls. Unfortunately, you got to hear your main teacher's voice again. Okay, today we will be doing the first part of linear function, which is points and interval. And now we'll be talking about the distance between 2 points, finding the midpoint of 2 given points, and also one additional 3-unit content called the division point. That means that point is no longer just the midpoint of the interval. It actually divides the given interval into a certain ratio. So the very first thing we need to do is just a recap of the distance formula. Now the distance formula, it's from the concept of Pythagoras theorem. So for example, if we have point A and point B with these given coordinates, to find out the distance between A and B, we generate a right angle triangle. And using, this is C, and this is A, and this is B. C squared equals to A squared plus B squared. However, the B, which is the vertical distance of this triangle, would be y2 minus y1. And the horizontal distance is x2 minus x1. Therefore, AB squared is equals to x2 minus x1 squared plus y2 minus y1 all squared. And if you actually want the distance by itself, we take the square root of whatever at the top. Do keep in mind, unless the question specifically asks for distance, the square form without the square root is actually more useful. And do remember, this is essential in extension 1. Do not draw a triangle again. Okay, the next bit we're going to talk about is the midpoint. A given interval. This time, we'll talk about midway through the 2 points. Same deal. We have the 2 given point with these coordinates. Okay, and the middle point, we always call it capital M with x and y. Now, I usually put a subscript underneath x and y to indicate this is the x coordinates of midpoint M and y coordinates of midpoint M. To derive the coordinates of this midpoint, we use two right angle triangles. And the distance here equals the distance here because it's a midpoint. These two triangles are congruent. So the first distance here would have a length of x minus x1. And the second distance in here would have a length of x2 minus x. Sorry, I missed the m in here. And they are equal because those two triangles are congruent. Now, if we make xm the subject, 2xm equals to x1 plus x2, and therefore xm is half of x1 plus x2. The y coordinates of the midpoint could be derived in exactly the same way, using y1 and y2. So therefore, for the midpoint, for the midpoint M, which has x coordinates of M, y coordinates of M, the x coordinates of M is halfway through the two given x coordinates, and the y coordinates of M is halfway through the two y coordinates. Okay, so basically that's what we have been doing before. Here is an example how we can actually simply use the distance formula and the midpoint to find something we want. Example, the interval joining 2 points A and B with the coordinates 3 and -7, and -6 and 2 is actually a diameter of a circle. Now, our job is to find the center and the radius of this circle. Now you can pause this video. You can pause this video, copy down the questions if you like. Okay, so to find out the center of the circle, which is the midpoint of the diameter, obviously. So in other words, we're looking for the midpoint of A and B. So let's say the center is a C with x coordinate of C and y coordinate of C. So the x coordinate of C, which is of course the midpoint of AB, 3 plus -6 over 2, which will give us -3 on 2. And y coordinates of the midpoint, which is also the center, is just add up the two y coordinates and divide by 2, which is -5 on 2. Sorry about that. I should write it at the front. So again, this is the center. Therefore, the center is -3 on 2 and -5 on 2. Now to find out the radius, which is half of the distance of the diameter. Now, the diameter, which is the distance of AB, we use a distance formula. Now, my preference is always just put whatever you like, the first or the second as x1 or x2, but you have to follow the same order. So if you start with 3, take away -6 as x2 and x1, the next one you have to do the same. Well, because it's a square, actually it doesn't matter. So therefore, oh my bad, there should be another closed bracket in here. So that's 9 square, which is 81, and that's another 81. Okay, so therefore it's 162. Therefore, AP is square root of 162, now which is 81, so that's 102. And therefore, the radius is, don't forget, it's just half of this. This is the diameter, 902 root 2. Okay. So up to this stage, we have go through midpoint and the distance formula. So the next thing we're going to do is the actual 3-unit content. We called it the ratio division point. So in this case, it's very unique. So you have to understand the background because we would have 2 different cases. Case 1, internal division point. In other words, your point lies in between the 2 given points A and B and divides the ratio somehow into something over something. Well, we will use some letters to represent that. That's called internal division point. The second case, on the other hand, is the external division point. In this case, your P can actually lie underneath or outside your given interval, which means is AP, it's an A length, and BP as AB length. In other words, P divides AB externally in the ratio of A to B. Those are the two different cases. Remember, the internal one is easier because it's kind of easy to look at. The external one is very difficult, especially if the question is given some other information. So let's take a look at case 1, which is we have the formula to talk about. So the ratio division formula. Before I present you the formula, you need to know where that comes from. Remember when we derive the midpoint, we use congruent triangles because midpoint has the same distance. However, this time we don't. So instead of congruent triangles, we would have similar triangle. Still the two given points. Now we have this. P is no longer at the middle. Just have xp and yp. Again, the subscript p here just indicates that it's the coordinates of p I'm looking for. Now in this case, we still have the two right angle we want, always, but this time they are not congruent, they are just similar. But the distance between point A to point horizontal distance between point A and point P stays the same, and point P to B stays the same as the same format as we got before. So the given condition is P divides AB in a ratio of, let's say, K to L. Doesn't mean AP has a length of K and BP has a length of L. It just means the ratio. So therefore, in this case, the ratio in between K, AP to BP is K to L. Because they are similar triangles, so therefore, the horizontal distance in here has the same ratio to the horizontal distance here. In other words, this distance over this distance still has the same ratio K to L. We do the same thing before. So the first horizontal distance here from A to point P is xp minus x1. And the second distance is x2 minus xp. And then we have this ratio K over L. And what we need to do now, we just cross multiply and try to make xp as the subject. So we would have lxp minus lx1 equals to, oops, should be bigger, kx2 minus kxp. Remember, xp is our subject. Put it on the left hand side. So lxp plus kxl or xp equals to lx1 plus kx2. Taking xp as a common factor out, l plus k equals to this, and therefore xp equals to lx1 plus kx2 over l plus k. So let me fix this thing first. And I'm trying to stop it a little bit. Okay. We'll continue on the next video.